Today we're going to talk about solving equations with variables on both sides. In order to solve an equation with variables on both sides, you're going to simplify one or both sides of the equation if necessary. So if it's possible to combine like terms and make a simpler equation, you're going to do that first. Then you're going to use inverse operations to collect the variable terms on one side, collect the constant terms on the other side, and then eventually isolate your variable. So let's look at an example. So here we're starting with 10 minus 4x equals negative 9x. So the first thing we're going to do is see if we can simplify, but I don't see any like terms that I can combine here. So now I'm going to try to get all of the variable terms on one side of the equation. Since I've already got a constant here, and I don't have any constants on this side, I'm going to get rid of the minus 4x by adding 4x. I'm going to do that to each side. Here I'm left with 10. On this side I'm left with negative 5x. Now I'm going to isolate my variable. I'm going to divide each side by negative 5. So I'm left with negative 2 equals x. I can always take any solution that I get and actually check it by plugging it back into the original equation, and this will tell me if my answer is correct. So I go back to my original equation, but wherever there's an x, I'm going to plug in negative 2. So I'm going to get 10 minus 4 times negative 2 equals negative 9 times negative 2. Now to solve this, I'm going to do order of operations. So my multiplication comes first. I get 10 minus negative 8 equals 18. So the right side's done. I've already found out the answer on that side is 18. 10 minus negative 8 can be turned into 10 plus 8, which is also 18. Both sides of the equation are equal, therefore my check shows that my solution is correct. All right, a key part of solving equations with variables on both sides is to follow these steps. The first thing you want to do is anytime you can use the distributive property to get rid of grouping symbols, you want to do that first. It simplifies your equation. So here's an equation with grouping symbols. I've got 3 times the quantity of 3x minus 4 equals 1/4 times the quantity 32x plus 56. So the first thing I'm going to do is distribute in order to simplify this equation. So 3 times 3x gives me 9x minus 3 times 4 is 12. On the right side, 1/4 times 32x gives me 8x plus 1/4 times 56 gives me 14. Now, if I could simplify this expression by combining like terms, I would do that now. I don't see any like terms that I can combine on either side. So now I'm going to get the variable terms on one side of the equation. I'm going to get rid of this 8x by subtracting 8x. But whatever I do to one side, I have to do to the other side. So I'm also going to subtract 8x here. And I am now left with x minus 12 equals 14. Now I need to isolate my variable. I need to get that x by itself. So I've got to get rid of this minus 12. I'll add 12 to each side. And I'm left with x equals 26. I can always take this x equals 26, plug it back into my original equation. And if both sides are equal, then I know I have the right solution. Equations aren't quite that simple all the time, though. Not all equations have one solution. Some equations don't have any solutions at all. So let's take a look at this equation. We have 3 times the quantity 5x plus 2 equals 15x. After distributing, I have 15x plus 6 equals 15x. In order to get those variable terms on one side of the equation, I'm going to subtract this 15x right here, so it cancels out, and I'll subtract 15x from this side. Here I'm left with 6, and on this side, 15 minus 15x leaves me with 0. Well, there's never a time where 6 is equal to 0. This is never true, which tells us that this equation has no solution. There's nothing that we could put in for x that would ever make these two sides equal. So this equation has no solution. A new vocabulary word for today is an identity. An identity is an equation that is true for all values of the variable. Thereby, this type of equation has infinitely many solutions, an infinity amount of solutions. So let's take a look at this example. I have negative 2 times the quantity 4y plus 1 equals negative 8y minus 2. So if I use the distributive property to simplify here, I get negative 8y minus 2. On this side, I also have negative 8y minus 2. That's where you should start to say, there's something different about this equation. But if we keep following the steps, we're going to get the variable terms on one side of the equation. So I will add 8y here to get rid of this negative 8y. And whatever I do to one side, I have to do to the other. So I end up with negative 2 on this side and negative 2 on this side. Well, negative 2 equals negative 2. That's always a true statement. There is always a negative 2 equals negative 2. So in this case, this is telling us that this equation has infinitely many solutions. No matter what we put in for x, it is going to work in this equation. So you can pick something else for x, plug it into both sides, and you will get two equal sides.